We evaluate high-end interfaces by their visual polish. We look for smooth animations, responsive grids, and flawless typography. To achieve that visual polish, developers often treat HTML strictly as a blank canvas. They construct complex layouts using an endless sequence of generic div and span tags, relying entirely on CSS and JavaScript to force those empty boxes into a specific design. When we strip away the presentation layer, the interface collapses into chaotic raw text. The browser engine translates this into an accessibility tree. Because of generic tags, it receives no structural data, seeing only a flat list with missing hierarchies. For a user relying on a screen reader or keyboard navigation, this flat structure offers no landmarks. There is no way to skip to the main content, identify the navigation menu, or understand the relationship between a heading and its paragraphs. A web page can render perfectly on a screen, yet remain entirely broken for parsers, search engines, and assistive technologies. To evaluate code quality, we have to stop looking at the human visual output and look at how the browser engine processes the data. HTML is a standalone, fault-tolerant data structure. Its primary purpose is to be read by machines, not to organize visual elements on a screen. Writing professional-grade code requires understanding exactly how the browser's parser builds the document object model and how semantic tags natively generate the accessibility tree. Older versions of HTML were based on SGML. SGML, or Standard Generalized Markup Language, is a strict legacy standard for defining document markup. HTML5 abandoned those rules to create its own highly resilient custom parsing pipeline. This diagram illustrates the input stage of that pipeline. The browser receives a raw stream of Unicode characters from the network and feeds them into a tokenizer. The tokenizer analyzes the characters and converts them into discrete packets of data, separating start tags, end tags, and raw text into recognizable tokens. Those tokens are then passed to the tree construction stage, where they are mathematically organized into the hierarchical nodes of the document object model, or DOM. This parser is reentrant. A reentrant process is one that can be interrupted in the middle of execution to handle a new task, and then safely resume exactly where it left off. During tree construction, the parser might encounter a script token, like a document.write command, which is designed to dynamically alter the page content. The tree construction stage pauses the tokenizer. It executes the script, injects the newly generated characters directly into the input stream, and then forces the tokenizer to resume processing the modified data. The browser is engineered to aggressively process characters into a structured DOM. Even if the author forgets closing tags or writes invalid markup, the parser will attempt to fix the errors and output a tree, making HTML uniquely resilient. Once the DOM is constructed, the specific tags used by the developer become active data descriptors. This side-by-side comparison shows how the parser handles different nodes. A generic div registers as a semantically empty box. A section tag, however, acts as a specific data descriptor. It generates an implicit ARIA role of region. ARIA stands for Accessible Rich Internet Applications, a standard that defines how elements are identified to assistive technologies. Semantic tags require proper internal structure to function. When an H2 heading is placed inside that section, the region acquires a machine-readable name, establishing a defined location in the document outline. Using correct semantic tags mirrors proper component architecture. It directly constructs the machine-readable outline, serving as the necessary bridge between raw network data and assistive technology. That machine-readable outline forms the accessibility tree, which relies on strict HTML attributes to establish a functional baseline. This logic flowchart shows the impact of the root document language. Setting the HTML lang attribute to English routes the text to the correct pronunciation rules. Missing that attribute forces screen readers to guess the language based on user system defaults, which frequently breaks pronunciation entirely. The parser also requires explicit instructions to handle images within the DOM context. Images that initiate actions, display data, or convey meaning are functional. They require descriptive alt text to pass equivalent meaning to the machine. Images used strictly for visual pacing or background aesthetics are purely decorative. Applying a null attribute, writing alt equals empty with no text, is a mechanical necessity. It explicitly commands the parser to strip the image out of the accessibility tree entirely, reducing noise for the end user. Automated accessibility checkers can detect if an alt attribute is missing, but they cannot evaluate context. They cannot determine if a description is accurate or if an image should have been hidden with a null attribute instead. These accessibility attributes are architectural baselines. Without them, specific data points are lost the moment the visual layer is bypassed. Keyboard navigation is the primary non-visual method for interacting with the parsed DOM. Programmatic focus must advance logically through the interface. Natively interactive elements, like button and anchor tags, are automatically inserted into this navigation sequence by the browser. This diagram illustrates a keyboard trap. When developers build custom interactive elements using generic div tags, they bypass the browser's native event handling. If focus gets trapped inside one of these custom components, the user cannot navigate forward or backward. Native focus management and programmatic labeling are strict engineering requirements. They guarantee the interface can be operated strictly through the machine's DOM API. We can now return to the high-end visual interface we examined at the start. This time, peeling away the CSS reveals a different architecture. Generic tags are replaced by a perfectly nested semantic DOM structure, utilizing header, main, article, and details tags. These tags natively assign exact programmatic roles to the data. This structured DOM translates outward into a robust accessibility tree. Every node displays a defined role, a current state, and an accessible name. An assistive technology, keyboard user, or search engine crawler can parse this tree to instantly identify the purpose of every element and navigate the hierarchy logically. The document's semantic structure provides a flawless, fully navigable API for any machine interacting with the web page. The browser translates raw Unicode characters into a document object model, and that DOM translates semantic markup into an accessibility API. Choosing a div when the data demands an article or leaving a functional input without a programmatic label is a failure in data architecture. It is not a stylistic preference. High-performance web development requires treating HTML with the same rigorous engineering standards as back-end logic. Code for the parser, and the presentation will follow.